Hello, everyone. It's just about the top of the hour here, so we're going to go ahead and get started. My name is Joanne. I am one of the community admins in the maintenance community. Thank you for everyone for joining today. If you're not already a member of the Slack group, I'm going to go ahead and add the link. We would love to have you join us. Today, we have James joining us for a presentation on spare part taxonomy, building the foundations of spare parts data. I'll let James introduce himself in a moment. The recording for today's session is going to be available in the Slack group tomorrow, along with the slides that you see here today. James is also available to answer any questions live in the Slack group. So any questions that we don't get to today, we can go ahead and move it over to Slack. And then the final piece of housekeeping, you'll notice your cameras and microphones are not turned on. So what you'll want to do is if you want to ask any questions, you'll put the chat feature on the right side here. So just chat your questions as they come up and we'll kind of go over them at the very end. And that's all for me. So thank you again for everyone for joining. I'm going to go ahead and hand it over to James to get us started.
All right, perfect. Thank you. Well, welcome everyone. Today we're going to talk about spare parts taxonomy. All right, it's really about building the foundation of our spare parts data. So those of you that I have not had the opportunity to present in front of or meet in person before, my name is James Kovacevic. I am the host of the Rooted in Reliability podcast. Aside from that, I work as a director of engineering, overseeing engineering and maintenance at a manufacturing facility. Have 3 young kids, beautiful wife, and 2 crazy dogs. If you're not familiar with the Rooted in Reliability podcast, it comes out weekly on Tuesdays, and you can find it all over iTunes, Stitcher, Spotify, so on and so forth. All right. So I've had the opportunity over the last 15 years, maybe a little bit more now, on helping organizations develop work management and spare parts management solutions. And there's a common theme that comes back to helping organizations overcome these challenges. And it's really about poor data. And that poor data stems from a variety of issues, which we're going to talk about today. But more importantly, what do we want our data to be so we can manage our spare parts correctly? Now, as we're going through the presentation, if you have questions, throw them in the chat box. I'll try and answer them as we go, as well as making sure we have some time at the end. But don't hesitate, throw them in the chat box and we'll go I'll answer as we go. All right, so we're going to talk about the story of poor data. All right, so there's many storerooms that I've had the opportunity to go into. And you walk into these storerooms, you look around, and there is a huge number of duplicate parts within that storeroom. And these happen for a wide range of reasons. Oftentimes, it's the same part with different OEM numbers. Now, what do I mean by that? It could be as simple as we have this bearing from this OEM manufacturer, and we have a bearing from another OEM manufacturer, but in reality, they are the exact same SKF bearing. But we've just set them up as OEM numbers, not the manufacturer number, right? And then we have other forms of duplication where it really is SKF versus NTN versus Temkin, and we have those types of duplicates as well. As a result of having all this duplication of parts within our storeroom, we usually stock a lot more than we actually need because we're covering mins and supporting usage during replenishment times for all these different parts, when in reality, it's the same part. So we end up stocking more than we need. Because we also have this high level of duplication, there's usually a lot of risk of obsolete parts. If we no longer need it over here, but it's only under this OEM number, we can't disperse those parts under the other part numbers without a lot of work. So we end up with a lot of duplication, a lot of obsolescence. In addition, we can't really leverage our spend. If we know what we're truly spending on bearings, for example, we can work with our suppliers to get better pricing. But when we have all these duplicates under OEM numbers, we don't have that opportunity. And then lastly, unless someone's really going into the storeroom and understands the parts in there, we might miss the opportunity to substitute like parts in emergency situations. This all comes down to bad spare parts data, more specifically, bad spare parts taxonomy. All right, that's why I say it's the foundation. It sets the foundation for our spare parts for a variety of reasons that we'll get into. Now, how did this organization get there? Now, if we do a miniature fault tree analysis, we can see that there's a lot of reasons why we get poor stock performance in our storeroom we just talked about. One is poor data governance. Now, what is data governance? Well, data governance is really the process of ensuring that our data is managed correctly throughout its life. How do we identify and set up new items? What fields are mandatory? What fields are optional? What's in those fields? That's all data governance. Now, if we ask ourselves, why do we have poor data governance? Well, there might not be a data standard in place. How do we name parts? You ask a lot of organizations and they'll try and say, we use a noun modifier combination. Others will just say whoever puts the description on the request sheet, that's what goes in. There's no review or cleansing activity, but it comes down to no data standards. And then we ask ourselves why again, and we get there's no perceived need for these standards. As a result, we don't do it and we're stuck with what we have. We could also have no defined processes. Now, defined processes could be the actual request process to set up that stock item. It could be the process to update our item masters and so on and so forth. Why don't we have those? Well, there's no training. Why don't we have training? Well, there's no perceived need again. Our people have been doing it for years. They know what they need to do. Then we have no stocking strategy. How do we set our mins? How do we set our maxes? How do we evaluate if we're actually going to stock this or not? We ask ourselves why? Well, there's no risk assessment. There's no stocking formula. And then once again, we ask why there's no perceived need. All these key things come back to we rely on our tribal knowledge. This is the way we've always done it. As a result, we're not getting what we should out of our spare parts. Now, why should we care about all this? Now, some of us on the call here, you guys understand well that if we don't do this stuff correctly, we're not going to have the right parts when we need them. We're going to have emergency expediting. We're going to have all these other things that we need to address. Now, my friends over at Activity pulled this from their website. What they have done over and over is work with organizations to improve spare parts data. This is only a snippet of what they have found to come from improving spare parts data, but it's the foundation of everything in a well-functioning storeroom. If we get our data right, then from a financial standpoint, we can reduce our carrying cost by 10 to 20%. Now, what's our carrying cost? That's the taxes we pay on our inventory. That's the cost we pay to cycle count it. That's shrinkage and obsolescence. That's all those things. Now, it's generally 20 to 30% of the inventory value. However, we can reduce that by 10 to 20% if we do this correctly. They also experience a reduction in 2 to 4% in expediting costs. Those are some pretty good financial numbers. Now, how does this impact work management? Well, we can get a 3 to 5% increase in schedule adherence, an 8 to 10% increase in wrench time because we can find the parts. We know where the parts are. It makes good business sense. And without having good spares management, work management is really going to struggle. And then lastly, purchasing. How do we get better at purchasing? Well, we can get a 2 to 5% reduction in pricing from our vendors because we're leveraging our spend. We're going to process less POs, which means our staff have more time to do more value-added stuff, such as more cycle counts, maintaining the spares in the storeroom, keeping the storeroom clean, and so on and so forth. If we get spare parts data right, the rest of this comes. It's the foundation. So how do we go about making sure we have the right taxonomy and spares parts data for our system? Well, we got to start with the end in mind. All right, and I say this because I've worked with some organizations who just want to clean data. They want to assign a naming convention, populate some fields, and that's all they want to do. And they don't understand either what they're going to do with that data or how that clean data is going to help their organization. So before we embark on any sort of data standardization, taxonomy development, data cleaning, we got to start with that end in mind. So these are some of the questions you got to be asking yourselves before you start jumping into data standards and data cleaning is what will this good data enable? Are we going to leverage spend? Are we going to consolidate spares and so on and so forth? How will I leverage that data? So it's great to say this is what we're going to do with it, but how are you actually going to get there? Are you going to have some of your storeroom staff dedicated a certain amount of time to reviewing obsolete parts, reviewing potential duplicates and flushing out duplicates, that sort of thing? How are you going to actually get there? Then what is the business case for data cleaning? Now, data cleaning in itself, you're not going to get a real good business case, but it's all the things you can do with that clean data. That's why we ask those other questions first. One of the other questions you gotta ask yourself is, what level of data quality or completeness is acceptable? I've worked with organizations where we've cleaned, 30,000 SKUs, 100,000 SKUs. Some of those SKUs we're likely not going to be able to clean very well. Why? They're very, very old, don't have technical data sheets, manufacturer doesn't exist anymore, they're potentially obsolete, or we know they might be going away in the next year or two when we replace a piece of equipment, so there's no point in cleaning those ones. And there's a diminishing return in the level of completeness. For example, attributes. If we want to start capturing ID, OD, width, seal type on bearings, a lot of those are going to be pretty easy to grab because we're going to have our technical data sheets. Some of them might not be easy to get. If that's the case, what level are we willing to accept? Are we willing to accept 80% because it's not worth the extra value? Probably. Now, what happens if we can't achieve the required level of clean data? Is that going to impact our ability to leverage it? Is it going to impact our business case? We got to think through these risks and identify what's going to happen. Then we're going to ask ourselves, what data needs to be cleaned? What will remain in that legacy state? Once again, that's looking at all the data we got to get through. Are we going to look at all of our spare parts, only our critical and A-class parts? Are we going to do our A and B parts? Are we going to do our A, B, and C parts? Separating out that, because there's a diminishing return on some of this stuff. And we may decide that our C-class parts are going to stay in the legacy state because it's not worth the effort. And then lastly, how are we going to keep this data clean? I have seen more than a few organizations go through a massive exercise where they develop a data standard, start cleaning their spare parts data, all those great things. And then all of a sudden, they're back at square one a couple of years later. They didn't have a process to keep it clean. So before you start doing these things, you got to start asking yourselves these questions. Now, there's a warning. Developing a business case for cleaning your data, standardizing spare parts data is difficult. Most of the analysis is going to be hypothetical. You're going to say, based on case studies and so on and so forth, that we'll be able to reduce duplicate parts by 10%. We'll be able to reduce obsolete inventory by 5%. We'll be able to leverage price improvements on 5%. But they're all theoretical or based on case studies from other organizations. So you're going to have a challenge there. You're also going to need to demonstrate the true opportunities. And really getting to that is it hard or soft costs? So hard costs, what are we not reordering? What are we not replacing? What are we going to reduce in our inventory value? Soft costs, that's could potentially be some of those carrying costs, we'll improve labor productivity, those sorts of things. In order to really work through that in your individual organization, you got to get finance on board with developing that business case. If you don't do that, it's going to be very hard to justify this stuff. And lastly, the way I've always approached it is you want to utilize a pilot to prove those savings before you move on to embarking on a complete data cleanse. All right, so pick your top 10% of SKUs, pick random 20%, clean those ones, show the value, get approval, then re-engage in a larger term project. Now, how do we get there? Well, it all starts with data standards. All right, and there's a couple different data standards that we'll talk about, but for spare parts, it really begins with that data standards. Now, the data standard, as definition, are documented agreements on representation, format, definition, structuring, tagging, transmission, manipulation, use, and management of data. All right, what does all that mean? Really, put it in perspective for me from a spare parts. How do we name the parts? What is that description? Is it bearing, comma, ball, comma, ID, OD width? Is it bearing, comma, ball, comma, manufacturer, comma, manufacturing part number? It's defining what that is for your organization in the constraints within your CMMS as well. Some of the common ones out there you will see for spare parts specifically is there's a NATO codification system that tells you how to define spare parts, and it's shared generally amongst aircraft, ships, land-based vehicles, those types of things, but it's a good starting point. There's another one out there, UNSPSC, the United Nations Standards, Products, and Services Code. These allow you to classify parts pretty easily, and then from classification, then you can drive some other activities. And then also, we may look at some of our ISO 14224 to see where do parts fit in on our overall hierarchy process. And we may have a separate data standard for hierarchy with taxonomy, and then the spare parts one that connects into that. So we got to have a good data standard. All right, now if you don't want to develop one, you don't have one, these don't work for you, we'll talk about some of the other options a way around that in a bit. Once we have that, then we got to build a process. How are we going to manage these spare parts over the life cycle of them? So as a generic process, we might have request part, approve part, verify and standardize data, create the item master, validate item creation, notify requester. It's a macro level process. Each one of these should have a sub-process that talks about how do we actually verify and standardize the data? What's each and every one of these steps required to complete this task? Included with that, then we should also have a RACI chart. Now, for those not familiar with the RACI chart, responsible, accountable, consulted, and informed. And for each and every one of the steps in these processes, we should have that clearly defined. Responsible, who's actually doing that step? Accountable, who's accountable for making sure that step is done correctly? Who's consulted, who might we have to talk about or have a two-way communication to get information from? And then from an informed standpoint, who's going to be informed that this step is complete? All right, so we want to make sure we document all that. That's going to ensure that our spare parts go into our CMMS clean and they're maintained in that clean state over its life. Now, once we have the processes done, once we got a data standard done, then we can start to build our taxonomy. Now, the taxonomy here, and I'm going to stick with the UNSPSC classification system for the webinar, but let's start back with what is a taxonomy. Well, taxonomy is a branch of science concerned with the classification, especially of organisms, systemics, etc. It also works for spare parts. Now, if we break down the UNSPSC classification system, it starts with a segment. All right, in this particular example, we're going to use a bearing. That falls under the segment of manufacturing components and supplies. Then we add 2 more digits to that, and then we get casting and casting assemblies. That's from the family. Then we move down into the class, which is bearings, bushings, worms, and gears, and you can see that number starting to develop. And then we get to the specific part, which is commodity, and we can see we have a number there for ball bearing. So anytime you're looking up using UNSPSC, we can look up 31171504 and get a list of ball bearings. It's a way to classify our parts. Now, classification of our parts becomes very important because we generally use that to drive different data requirements for our parts, and I'll get to that in a moment. Now, this is the UNSPSC. You can use NATO, you can use your own internally developed ones, and there's also commercially available ones to purchase, all suiting different needs. Right. Now, once we've classified our parts, then we can get into the naming side of things. So from a naming standpoint, it's really what is going to be in that short or long description within that CMMS. It's usually a combination of the part name and some key attributes. Certain organizations will put manufacturer part number in that. I'm not a fan of that because there are already predefined fields within the CMMS for those items. We may include abbreviations to overcome field size limitations as well. For those of you that use SAP, 40 characters, short description for a spare part. Very hard to get that information in there. So if we take this ball bearing for an example, we got our inner diameter, outer diameter, and width. It may go into the CMMS as BRG, ball, 35 millimeters, 72 millimeters, 17 millimeters. And everyone knows that that is IDOD width. You may include seal types as well. You may have a long description that includes all of that, plus manufacturer part number, and so on and so forth. You got to shape these to your unique CMMSs. All right. Now, becomes a challenge to do some of this stuff, especially if you have multiple sites using the same CMMS and you're trying to align to share inventory. We'll get to that a little bit later. Based on our attributes or based on our classification. So if it's ball bearings, for example, we may want to capture different information for that versus bearings, versus motors, versus gloves, and so on and so forth. And there may be certain commodity codes or classes of parts that we don't want to capture any attribute information because it's not worth it to us. Maybe we have 2 items in there and we use them at a very infrequent level. Probably not worth capturing all that data. If we use a lot of motors, a lot of bearings, even a lot of gloves, we may want to capture that so we can leverage pricing, put stuff out for e-auction, and so on and so forth. The key behind this is we really only want to collect attributes that provide value to the organization, right? So for motors, we might be looking at voltage, horsepower, frame. Bearings, ID/OD with seal type, gloves, material, and size. There might be other parts like guide rails that we don't want to capture any of this. It might just be length and width, and that's it. Or we may not even capture that, and we might just leverage the OEM number because we know we're never going to purchase it from anywhere else. The requirements for attributes and specifications should be driven by generally the classification of that particular part. Some of the other challenges we have when we got to build these data standards is units and abbreviations have to be standardized and defined as well. All right, most CMMSs do not have the capability to search for multiple iterations at the same time. What do I mean by that? If I type an inch, is my CMMS going to return everything with a IN or a quotation mark or so on and so forth? Probably not. I'm going to have to do 3 different searches. So standardizing these is critical. For inch, for example, we might want capital I, capital N, not abbreviation, not spelled out, and so on and so forth, IN. Bearings, because of space limitations in some of our fields, we may want to have BRG only as our name for bearing. Not bearing, not BERG, nothing else, it's BRG. We got to standardize these as well. All right. Now, if we don't have all these data standards in place and a process to manage it, what happens? Well, we may have these bearings all set up in our storeroom. 4 different bearing SKUs or item masters set up in our storeroom, all the exact same bearing. All right, you can see some here. We have a couple referencing line 5. One says SKF, one doesn't. One's abbreviated, one's not. We've got the same bearing used on line 9, spelt incorrectly. And then we also have one on line 10, but we don't have the seals on there. As a challenge, all these are really the same bearing. This should be one item master attached to the bill of materials for the various lines or pieces of equipment, not 4 separate ones. All right. So with these, with a data cleansing activity, we can actually consolidate all of these into one. Now we can really leverage our spend. And not only that, when we set up our storeroom, we have one location for these bearings, not 4 locations. Because if these were all set up under independent OEM numbers, we likely have it set up across the storeroom in 4 different locations. Takes up extra space, makes it harder to manage, all those other things. Now, if we set up a proper taxonomy, we may have parts in our CMMS that look like this. You can see that top one, we got our ball bearing. We have a ball valve identified there. We know it's a 2-way, 2-inch, 150 PSI rated. We got motors there. We got other ball bearings identified further down. It's very easy for people to find what they're looking for, whether it's attached to a bill of material or not. It's also easy to identify duplicates because now we can identify, we have these, for example, 10 different 6206 bearings in here. We can easily identify it and start working through and eliminating those duplicates. All right. So now we kind of understand why we want a taxonomy, what's included in it. The big thing is really, how do we apply this taxonomy? And that's not always easy. All right, there's multiple ways we can do it. And let's chat about some of the options we have. There's a manual way to do this. I've worked with organizations who build their own data standard and taxonomy in a spreadsheet, and they honestly have someone there who is looking at each part, building it based on their rule set in their Excel spreadsheet, and it leads to a lot of issues. It's prone to mistakes. Generally, it's a lot less expensive to set up and get going, but it requires that internal dictionary to be developed. So you're identifying for a roller bearing, what are the attributes I want to cover? How do I abbreviate them all? So on and so forth. You're doing the same thing for ball bearings, same thing for thrust bearings, and so on and so forth. It's a lot of work to gather all that information and set up the standard moving forward. The other thing is with these manual approaches, they're often subjected to workarounds. People will find ways to get around it. They'll skip it. You're prone to data entry mistakes. It's just not a good solution. Now, there's some other options out there. There's a software solution. And what that really does is it reduces the likelihood for mistakes because you put the data in. It automatically generates a short or long description based on your unique rules, your attributes, your abbreviations, and so on and so forth. You have to provide the characteristics though for most of these. What do I mean by that? If you type in a 6206 bearing or 6207 bearing, you have to put the ID/OD width in there, the seal type in there. But it consolidates it all, it makes it easy to search, and it builds a proper description for you. Generally, these software solutions will include a governance process. It'll include a workflow approval process. It'll include data quality checks where it automatically checks for duplicates based on part numbers, based on attribute values, those sorts of things. Some of them come with a preloaded with a dictionary. So it'll already have combinations of now modifiers, what attributes are associated with each one of those classifications, which ones are required, which ones are optional. It already comes preloaded with that stuff. The big advantage, it identifies duplicates easy and it makes this process a little bit easier. But once again, you have to do the research for each part. Then you have solution providers that do this for you as well. Generally the most expensive. And in this instance, a solution provider, you would log onto a web portal or something, and you would put the description, the manufacturer part number, and then they would go do the research for you. They would get all the attribute data for that part. They would populate it. They go through a quality control process. So by doing so, we get a very high level of data quality. They can clean and standardize high levels of data. Oftentimes, these solution providers have their own internal database. So even if it's an obscure OEM part, not a standard part, they may already have that data, so they can turn that over pretty quick. They can cross-reference OEMs to manufacturers as well. So they'll identify that not only is this a duplicate from a manufacturer perspective, but this OEM is actually the same as these 4 different manufacturer parts. And they can provide that information very, very quickly. But it's a bit more expensive. All right, so you have to decide when you start looking at data quality for spare parts, what approach do you want to take? All right, I've used all 3 of these. There's pros and cons with each and every one of them. It really depends on your site. How many resources do you have? What level of quality do you want? What is your end goal with the data? So where do you begin for all this? Well, the first thing you got to do is define the future state of data. So that's really building that data standard and identifying where do we want to be in the future. Then we define our current state of data. So we can identify what is the work we need to do to close those gaps. By doing so, we're going to estimate the workload or cost. For example, we may have to clean 30,000 SKUs. That's going to take a while, especially if you're doing it manually. So then you can estimate the cost there, and then you can estimate the cost of having a solution provider do it for you. Then you determine who will clean that data. From there, which class or commodities are high priorities? If we consume a lot of bearings and we know we got duplication issues with bearings and obsolete problems with bearings, we may classify those. Same thing with motors and valves. We may not worry about belts or brackets right now, but we're going to prioritize which ones we want to do. From those, we're going to define which ones require those attributes. Some, it might be simple as, especially with OEM specific parts, description, manufacturer part number. That's it. For some of the more commodity type parts, we're going to include more data. From there, we got to get our stakeholders aligned. Make sure that our maintenance team agrees with the taxonomy, our IT agrees with it, procurement agrees with it, engineering, and so on and so forth. So everyone is moving this forward together. Then we're going to define that pilot area or pilot group of parts. We're going to do that work on that pilot area, work through the future state of that data with those parts we cleaned in that pilot area. Really identify what is the ROI for cleaning these parts initially. Did we see a reduction in duplicates? Can we leverage spend, so on and so forth? Because that's going to help us build the business case to expand this data cleaning to the rest of our SKUs. Right? Now from there, a few other things. There's going to be rough seas ahead. It's going to be hard to do this work. When you learning from past mistakes, learn from my mistakes. When you build that data standard, ensure stakeholder alignment, but get it in writing. I've had people agree in the past that this is the right, yep, I agree, it's good data standard, good naming convention, let's do it. Push comes to shove, I never agreed to that. Get it in writing, have your stakeholders sign off on the charter. Don't aim for perfection when you're cleaning your data. You're going to find that if you're doing it internally or externally, there's going to be some parts that you just can't get good data for, whether it's attributes, lead time, pricing, whatever it is. Don't aim for perfection. There's going to be a diminishing return. And that's where we have to understand early on is where are we willing to accept some level of poor quality data or missing data and work through it from there, right? Old parts that we know we may never order again or so on and so forth, probably not worth the effort. Sometimes you got to be afraid to leave legacy data as is. It's not worth the effort, especially if you're constrained in cost. What you may want to do is clean your high priority groups or classes of parts, leave your other stuff as legacy items. And then as you add those parts and those parts get phased out, as legacy parts gets phased out, we don't worry about it. But as we add new parts, we apply the new data standard moving forward only. We're not retroactively cleaning. Sometimes that's the right approach. Biggest, most important, have a plan to maintain that data cleanliness. Who can actually create an item within your CMMS? Not everyone should. We should only have a couple people that actually have access to master data records. How do we update those? What's the approval process? How do we update our data standard? Do we have enough resources to make sure we're doing those types of things? That's critical, because what we don't want to do is spend a bunch of time cleaning our data and then come back in 3 years and have to do it again. So to that point, how do we sustain the data quality? Well, need to establish that process for new item creation. All right. Who can submit, who can approve, who does the data cleansing, who loads it into our CMMS, who provides that new item number. We have to establish an exception process. Many organizations will not allow you to order a part unless you actually have a number set up in the CMMS. So the exception process is, I'm in an emergency situation, maintenance needs this part, we need to order it, but we don't have a SKU number. So what do? They set up a SKU number, but then there's an exception process where the data quality team will loop back, review that, fix any data quality issues with that item master within a 24 or 48 hour period. So we're not delaying maintenance and operations from getting back up, but we have a way to come back and make sure that data is clean moving forward. We want to reduce access to new SKU creation in the CMMS to a few key people. We want to establish some data quality KPIs and monitor those. That might be how long does it take from request to new item created. It might be looking at number of items with missing fields that we consider mandatory or required. A couple different ways we can do it. And then lastly, most importantly, we want to embed this new process into project and CapEx processes. If we're expecting our existing storeroom staff and maintenance group to do this when they get a new item handed over from projects, we're going to be overwhelmed. So we want to embed this process into the capital process or project process. So it's all the new SKUs are cleaned and created in our CMMS prior to turnover to maintenance. SKU, good question. SKU, stock keeping unit. It's the same thing as item master, those types of things, or a unique part record within your CMMS. All right, so what do we do once we have all this done and we have it ready to go? Well, we start to leverage our data. So we want to identify exact duplicates and consolidate. Exact duplicates, SKF 6207 2CZ. We identify all those, consolidate those. Then we want to identify fit form function duplicates and consolidate where possible. What do I mean by that? That's where we start looking at this SKF versus this Temkin versus this NTN and consolidating all those into one unique part. That's individual bearing, and then having our approved supplier list or approved manufacturer list, which might be prioritized from SKF to Temkin to NTN and so on and so forth. Where possible, we want to move those OEM parts to manufacturer parts. So depending on what industry you're in, you might have a Gould pump, and within there's a bearing, and that Gould has their unique number for it. We know that's a SKF, whatever. Let's convert that to that SKF number now. So now we're not buying directly from that OEM. We're getting a better price from the manufacturer. We can leverage our spend. Once we've consolidated all of these parts, what we want to look at is revise our stocking levels based on usage. Now that we understand how many of these bearings we're truly using, we're going to want to revise min-maxes using some formulas and so on and so forth. On those high use items, we're going to want to take those again. We're going to want to negotiate pricing on those high use parts because we've consolidated it. We have a better understanding of what we're actually doing with it, how much we use, how often we order. We want to consolidate and leverage our pricing on that as well. From there, leverage spend on our high volume suppliers. So if we know we're buying a ton of power transmission stuff, but it's from all these different suppliers, and once we do our duplicate consolidation, most of it's going through Motion, then we want to go to Motion and say, hey, we're spending X amount with you each year, what can you do? And do the same thing with various other suppliers to try and get better pricing. Lastly, we want to reorganize that storeroom. Now that all this has been consolidated, there's no need to have all these different bearings set up in all these different locations. We want to move them all to a single location so it's easy for everyone to find. We're not cycle counting the same part across 5 different spots. It makes it a much smoother running storeroom. All right. So if we get our spare parts data right, we have the ability to reduce our inventory holding, improve data quality, improve our spend, reduce stocking levels. It's a huge, huge enabler of everything. I referred to this process in the past as gatekeeping the storeroom. Let's evaluate our parts, set them up correctly, risk rank them, stock appropriately from the beginning so we don't have high level of obsoletes, high level of obsolescence parts, too much of the wrong parts, not enough of the right parts. If we do this properly up front, we'll reduce all those problems in the long run. All right, with that being said, I'm open for questions.
Alrighty, we have a few people typing. Just let them kind of type their questions in. I do have a question for you though, James, the personal one. So I know there's a ton of importance, as you just said, in spare parts and the data. So I kind of want to like relate that to the supply chain, just because I feel like it affects the demand and like fulfillment cycle. So I want to ask, like, what are your thoughts on organizations who are using the method of stockpiling their inventory and raw materials? A lot of manufacturers are using like the just-in-time method. How would you, or what are your thoughts on how that affects spare parts and how that affects the overall supply chain?
Yeah, so there's a couple different things with that. I think as we evaluate spare parts coming into the storeroom, we have to identify how important is that part. Is it a significant risk to the business? What's the lead time? Are there workarounds? All these other things. And if the answer is it's a very extended lead time, there's no workarounds, we're going to shut down the plant for 6 or 8 weeks, then we're going to have to look at potentially safety stock, not advocating we stock 30 of them, but we could potentially have to look at safety stock and increasing mints a little bit, better managing that lead time, those sorts of things. If it's other parts that are not as important, we can substitute with others, that sort of thing, then we're going to not carry just as much. And depending upon the maturity of the organization, those parts should be typically reserved for emergencies, and we're ordering parts for planned work as part of the work management process, the work planning process. Now, if we're still early in our journey of maintenance maturity, we're going to have to order those other parts to overcome our gaps in the planning process. Does that answer your question?
Yeah, no, I just kind of want to hear about like your perspectives on it, just because I know it has a huge role in just making decisions in terms of ordering those spare parts or having that kind of more locally than it is, so that you can have it always on hand.
Yeah. And that's where,
yeah, go ahead.
That's where working with your local suppliers helps as well. Maybe they carry it on their shelf. In all honesty, one of the biggest things I see too is organizations don't update their lead times in their CMMS, or they're inaccurate. So then our mins become inaccurate, which results in stockouts.
Gotcha.
So connecting it to the supply chain is very, very important. And the more critical the part, the more we want to update that lead time data, that sort of thing.
Gotcha. Well, how do you feel about like organizations, regardless of looking at the data and knowing that they need to prioritize which parts to kind of stock up on, but instead they're kind of listening to the customer demands and just trying to like think ahead, and they're trying to just get as much inventory as possible and raw materials so that they don't have to worry about this in the future. Like, how do you feel about that method?
There's got to be a risk ranking. There's got to be some sort of process that you walk through, because if it's completely up to people's intuition, gut feel, we're generally going to overstock the wrong parts and understock the right parts. So if we have a process defined that we can walk through and say yes, no, so on and so forth, if it's not working, we can revise that and update it moving forward. And I think if we're looking ahead to some of those types of issues, we want to make sure we have that process in place so we can evaluate it objectively.
Gotcha. All right, cool. Well, thank you for sharing that. We have a question here from Joe. He asked, how would you go about putting custom-made parts for custom equipment into the proper standard nomenclature for the parts descriptions?
All right, great question, Joe. This is often a challenge. So if you work with a very specialized equipment manufacturer, or you doing something internally yourself, what we would generally say for that is you would have a very basic taxonomy or naming process for it. It would be bracket, for example, and then that might be it. And you might reference a drawing number with it, or you might have bracket and then it's just a manufacturer part number with it. You don't have to go into attributes for a lot of those because it's a custom part that you're likely only going to get from that one individual or that one organization. So you can scale the descriptions accordingly based on the importance of having that data. Essentially, if I know I'm only going to ever order this part from this one single supplier, because it's a custom machine, specialty machine, so on and so forth, I'm not going to worry about populating all that attribute data. It's going to be basic description, usually what they have in their manual or their drawing, followed by their part number and their description. Their description.
Cool, thank you. A few more questions here from Volker. How and what could a control KPI for such a database contain?
So if I get this correctly, for data quality, we generally would look at turnaround time for new SKU creation, right first time for new item creation. You might also, depending on as you're going through the process of cleaning your existing data, you might look at percentage of items that have been cleaned to the new standard. And in the past, we actually wrote a script for another CMMS that would actually go through and check various fields against a list we built in Excel. And if the noun modifier classification didn't match what was on that list, it flagged us. And if there were certain key fields empty, it flagged us. And we use that as a overall data quality index is what we called it.
Cool. He also asked, would there be a follow on Webby on items like RLP, MRP, stock risk, lead time evaluation, min stock, etc.?
Yes. So interestingly enough, I think I did one or two of these already with the Upkeep community. So those are available, I believe, on the Slack community, and there's one or two out there from either PMAC or SMRP that I have done in the past as well. But I believe I've done this once or twice on the maintenance community already. So if you can't find them, let me know and I'll dig them up for you.
I'll do the same. And then another question from Usman. For bearing with ID, OD, etc., there could be multiple suppliers with multiple pricing options. Normally, purchase departments need details and material descriptions for supplier preference as it affects costing. How can we manage the same parts with multiple suppliers? It happens normally due to availability issues, etc.
Yep, great question. Depending on the system you're using, what I find in a lot of CMMS's EAMs, you may have your item or SKU master, and then you can actually attach multiple suppliers to that individual SKU, and you can sometimes prioritize, this is supplier 1, supplier 2, supplier 3. So if there's issues with one, the system will go to the next and to the next. So you connect the different suppliers with their part numbers to that individual part.
Cool. And then Moretti says, hi, James, is spare parts taxonomy based on WBS?
Is it based on a work breakdown structure? It's a similar type concept. The UNSPSC goes through a lot of that, and it actually, if I'll back up on the slide for a second, might help. Where are we here? So the UNSPSC actually breaks down through all of these, so it is kind of like a work breakdown structure. You can download, I think, the Excel version for free from the UNSPSC classification system. You can just Google it and it'll come right up. You can get it on there. There's a lot of others out there. Spares Finder, There's Activity does it. There's IMA Limited. There's quite a few others that have these types of taxonomies, classification, and data cleaning processes for spare parts. They're generally proprietary, though, and you're going to work with either their software or as a solution provider.
Another question just came in. What process steps would you recommend if a supplier provides a part upgrade with new descriptions, superseding part numbers, etc.?
All right, so good question. I would say this is going to depend on the organization. Some organizations would create a new item and discontinue the old one. That way there's no confusion that this is version 1, this is version 5, right? So they manage their management of change very well, and they create a separate item for those and close out the old one as discontinued and so on and so forth. Depending on the CMMS, once again, some of them allow you to put discontinued in the item master and the follow-on part number, so it'll automatically direct people to that new one. If it's a small minor revision, then what you may do is just change the description slightly, Rev B, Rev C, something of that nature, so everyone knows what that latest part is. And it also depends on industry and criticality of the part. There's a couple things there that you may want to consider when looking at that specifically.
Awesome. Okay, I don't think we have any more questions. Alrighty, well, I think that concludes our webinar. Thank you again, James, for kind of coming here and spending your time teaching us all about spare parts. And thank you all to all of our viewers here for asking questions. I think we got some good ones. But if there are any further questions you want to ask James directly, feel free to go back into our Slack. I do see a person typing, so we'll just see if someone's asking a question. But thank you again, James. The recording and the slides will be provided tomorrow, and I'll also look up past webinars that James did and provide it in our Slack group as well, just to have it at your disposal. But I think we're all set to go here. Any last words, James?
No, thank you so much. Feel free to reach out in the Slack group, LinkedIn, whatever works for you guys, and more than happy to answer any questions you guys have.
Awesome. Well, have a great day, everyone. Bye.
Thanks, everyone.